A body is said to undergo simple harmonic motion if its acceleration is always directed towards a fixed point, and the second one is if its acceleration is directly proportional to a distance towards the fixed point. Now, under this channel, I don't like talking too much. Let's go to the calculation proper. Now, the period which is t is the time taken all over the number of oscillation, while the frequency is the number of oscillation all over the time taken. Like I said, I don't like wasting too much time here, and I already said, remember, this is measured in seconds while the frequency is measured in hertz. And I said a relationship is, we have that between the linear velocity and the angular velocity is V is equals to WR. Let me call this equation 1, call this equation 2, and this is equation 3. Now, this is the linear velocity in meter per second. This is the angular velocity in rad per second. And of course, this is our the radius. And so from here, remember that W is equals to 2 pi f, and then we call this equation 4. Now from here, from 4, I want to make f the subject of the formula. So your frequency is W all over 2 pi, and that is equation 5. Please calm down. If you don't know this formula, you can't solve anything under simple harmonic motion. We have up to like 20 formulas I'm going to drop. So these are the introductions. So calm down and be writing it down in your notebook. So this is equation 5. But note that frequency is 1 all over period. That's why another SI unit of frequency is per second, because it's 1 all over period. And so if from equation 5, if F is equal to WR, and then this is equation 6, and from equation 6, frequency is 1 all over T. That means that your period is 2 pi all over W, and this is equation 7. That is equation 7. Now, note something again. That W is, the angular velocity is theta all over T. And that your theta is the angle turned by body. The angle turned by body. We have a relationship here. Let me call this equation 8. All these formulas I'm releasing here, I'm going to use it to solve equation. That's why I'm writing it now. Because after the introduction, the other formulas I'm going to be using, I may not be able to be writing it like this. Now, I want you to also know something. That theta this is equation 9. The period is 2 pi m all over k. And if this is so under equation 9, remember from equation 6 that the frequency is inverse of time. So all I need to do is just turn it. That means from here that my frequency is now 1 all over 2 pi into bracket k all over m. And this is equation 10. Now, notice also that your period and this is equation 11. Note this thing into your writing book. We're going to all use it during solving. It's very very necessary. Please note this. This is a very important formula, that T is equals to 2 pi L all over G. This is equation 12. L all over G. And I know from Hooke's law that F is equals to KE. This is equation 13. Where this is the force, here is the constant, and of course this is the extension or length. Note all those formulas there, and please know this very well, that of course I already said that mass is force times acceleration due to gravity, which is KE. This is another equation, that is equation 14. Now let me stop here. Let me not just be writing equation. Let me start giving examples so that we can start solving, so that you see how this thing relates. We have example number 1 here. So a particle moves in a circular orbit of radius 0.02. So the radius is 0.02. If the speed of the particle v is 0.888, calculate the frequency in circles per second. Of course, that is the frequency. Now, the relationship, we have this, we have already proved the formula. Now, I have v, I have this. So, making angular velocity the subject of the formula, we have v all over r. And this is 0.88 divided by 0.02, right? So 0.88 divided by 0.02, you should get an answer of 44 rad per second. So you should get 44 rad per second. Now the next thing is, we want to calculate the frequency, and we already know that this is equal to 2 pi f. So making f subject of the formula, we have this all over 2 pi. So this is now 44 divided by 2 times 3.142, and that should give you an answer of 7. That should give you 700. So this should give you 7.00 per second, or 7.00 hertz. Frequency have 2 SI units. Now the second example, which is the example number 2, we have a very sweet question. They said the period of oscillation of a particle executing simple harmonic motion is 4 pi seconds. So the period T is 4 pi seconds, right? If the amplitude of oscillation, which is R, is 3 meters, calculate the maximum speed of the particle. Calculate the maximum speed of the particle. From the formula I've already dropped above, can you pause the video and try to know if you can solve it yourself? Try to pause the video and know if you can solve it yourself. We already know that for when we calculate the speed, we already know that V is equals to WR. Now, we already have R, but we don't have W. But we have a formula that relates the period to the angular velocity, and that is that period is equals to 2 pi all over W, and that's the formula that relates the two quantities. And so from here, all you need to do right now is we want to get our angular velocity to solve here. So I'm going to make the angular velocity subject of the formula, which is 2 pi all over T, right? So this is 2 pi all over 4. Of course, 2 times 3.142 divided by 4. If you punch it in your calculator, the answer you should get should be 0.5 seconds. 0.5 seconds. Of course, there's also 2 pi here, so pi cancel pi. So you have 0.5. You have 0.5 rad per second. So all you need to do is, this is WR, so 0.5 times 3. So whatever you get, that should be your answer. So 0.5 times 3, that should give you 1.5 meter per second. So the velocity here is 1.5 meter per second. So that's why I was wasting time trying to ensure that we do a lot of solving when it comes to simple harmonic motion, because there's a lot of calculation that comes with it. So please, this is the part 1 of the video. Let me write it under simple harmonic motion. We have released a lot of videos under this, so keep up with us. Thank you very much.